Hello, this is Abnu Patidar. I'm a third year student of IIT Bhubaneswar. For my DSP Lab 4, I have written a code which aims to remove baseline order high frequency noises and power line waveforms from PPG signal of sampling frequency 100 Hz using first order HPF and then passing it through LPF. So for this we'll first define four variables and arrays, which will be constant integer capital N is equal to 1000, which will be denoted, which will be used to denote the size of the array. Next we have float x of n, and in this one we'll put our initial PPG data derived from the signal with 10 EWGN. Next will be float HPF out of N and float LPF out of N. They can be seen as their as the variable name says, array name says, HPF out will be output of the HPF and LPF out will be output of LPF. So for this, first we have loud void setup loop, in which we will put our setup code. For the starting of the operation, we'll put serial.begin 96100 where 96100 is our baud rate. Next, since it's a causal system, we'll put HPF out 0 is equal to 0.9843 star x of 0, neglecting the x n minus 1 terms uh, from the equation of y of n, as this is a causal system and we can't have minus 1 x of minus 1. Next, we'll put a for loop from integer at index 1 to n minus 1, in which we'll find out the value of HPF out for those indices according to the pole zero placement method. For an HPF with lower cutoff frequency 0.5 Hz, we have HPF out I is equal to 0.9843 star x of I minus 0.9843 star x of I minus 1 plus 0.9686 star HPF out of I minus 1. Then this uh, waveform obtained, intermediate waveform obtained after HPF will be then fed up to LPF. So we'll have LPF out of 0 as 0.1571 star HPF out 0, and as same as the above, we'll have LPF out value in a for loop from I is equal to 1 to n minus 1, and the formula for LPF out of I will be 0.1571 star HPF out I plus 0.1571 star HPF out I minus 1 plus 0.6358 LPF out I minus 1. So after this all calculation, we'll jump into void loop, and void loop will just continuously print our signals. So first we'll print x of I, which will be the original signal. Then we are printing HPF out I minus 250 to the just like translate the whole signal sequence by minus 250, as it will be clear to see the difference between waveforms after they have gone through the HPF and LPF. And next again LPF would put it further down with minus 500. Now let's see what like I have already uploaded the code. Now let's see what we get from the plotter. So by seeing this, we like observe that the blue one is the original signal with 10 AWGN. And next red one is the output of that HPF, which has removed some high frequency components, but the signal is still too much, still has too much noise. So when we pass it through the uh, LPF with upper cutoff frequency 5 Hertz, I tried it and then I have got, I can see that it really smoothen out the input PPG signal. So there's that. Thank you for watching.